And I'd like to thank ASPI for inviting me. I'm delighted to be here and have this opportunity. The title of my presentation today is Keeping Major Ship Acquisitions on Course, Key Considerations. It's difficult to predict what makes a program successful, but what I'm going to share with you today are those attributes that, if they're not addressed, will yield an unsuccessful outcome in terms of cost growth, schedule delays, and performance shortfalls. My presentation is going to be uneven. Since RAND is new to Australia, I suspect most don't know much about RAND, so I'm going to introduce RAND with one chart. Then I'll provide some background on why RAND was asked to support the C5000 program. Then I'll turn to the substance of the briefing and talk about what lessons we've learned by acquisition phase. Well, what is RAND? Okay. RAND is an independent, nonprofit institution. It was formed shortly after World War II by a series of Air Force generals who wanted to make sure that the technology, operations research, and a lot of the analytical techniques weren't lost and dissipated after the war. We have offices in the U.S., Europe, and have recently established a presence here in Canberra. We're policy advisors to the senior executives and decision makers around the world. We also have the largest PhD granting institution in policy analysis. And I think we're best characterized by the fact that we're not a university nor a management consultant, but we have the capabilities of both. At RAND, we have about 1,700 staff members, over half hold doctorates, 1/3 have master's degrees, and last year we did about $250 million worth of research. We're the principal study house for the U.S. Air Force, for the U.S. Army, and for the Office of Secretary of Defense, and that latter organization is where a lot of our maritime work falls. RAND produces about 350 reports a year, about one a day, on a broad range of national security and domestic policy issues. And these are available on our website, just www.rand.org. RAND has a strong tradition, and for every project that we do, we publish a report. We think the best disinfectant is sunlight. And these reports are all on our website. It's also important to point out that we don't design or build anything. Oftentimes when government organizations come to us, or we don't work for anybody in the private sector, it's really a kind of a thorny problem, and we're often viewed as kind of the honest broker because we don't have any skin in the game. Acquisition policy has been a major theme at RAND, especially with our maritime work. Okay, we have, I'd say, probably 50 plus, or close to 100 probably now, reports. This is just a short example of some of the work that we've done for the U.S. and for the UK. And it's interesting because Chris and I, his paths have crossed a lot in the past. We worked on the Type 45, I think, together, and we also did some work on the UK's future carrier, where RAND was helping them with their acquisition strategies. So we have lots of experience across all the platforms. We worked the subsurface, surface, and air systems for the US and the UK. And we're kind of getting there with Australia, okay? We've done some submarine work, and we're doing some work for the C5000 office and some other work as well. In 2014, the DoD asked RAND to help with the future frigate program as they develop an acquisition roadmap. As with any large, complex military acquisition program, the C5000 program needs to understand various paths and steps it could take in designing, building, testing, and supporting complex naval ships, and the implications of various decisions it might make along those paths. Faced with the need for greater insight, the C5000 program in early 2014 commissioned RAND to help explore these three acquisition questions. What are the options? What are the implications of those options? What are the phases and the kind of decisions that they're going to have to consider as they move through the acquisition process? And what are the important aspects that contribute to a program's success? This chart kind of shows that really the future frigate has three options, okay, and they're shown as the column headings here. Military off-the-shelf MOTS, and what I mean by that is a real MOTS where there's no modification to the ship, very much like the FFGs, which were built in the U.S. and then really built to print here in Australia, the latter ones. There's also an opportunity to evolve MOTS, and this has been discussed earlier, where the basic HM&E goes through an Australianization, and we've seen that with Collins and the air warfare destroyer. And the final option, of course, is a new design. Okay? And that, of course, would be tailor-made to Australia's specific requirements. Each of these options, and I recognize this is a busy chart, and I've actually got two of them, entail different risks and implications for the acquisition process and strategy. The pure MOTS solution, which most likely would be built outside of Australia, would probably entail a lease design and cost risk, given that it most likely would be with an experienced builder and a warm supplier base. The evolved MOTS option would entail more design and build risk that would increase as the ship's design diverges from the baseline. And on this chart, we talk a little bit about a new design would probably present the most acquisition risk, okay? But the operational risk would be reversed to some extent, assuming that each option performs to specifications. The clean design specifications could be tailored to the specific needs of Navy. The pure MOTS option is a fixed design, so Navy would have to adapt probably its operations to the ship and may not get every option it desires. As you all know, shipbuildings go through multiple acquisition phases. I think one of the most important parts of that phase is the solutions analysis. And at RAND, we have lots of experience with that, and there's three basic questions you've got to ask there. Do what, with what, how well? Do what question is really a government function and addresses the challenges of how far do you want to go, how long do you want to stay, and what do you do when you get there. And once you have those scenarios, you can begin to develop measures of performance and measures of effectiveness. And then those are the criteria when you come down to the with what option. And the with what option will have multiple choices. It could be a MOTS, a modified MOTS, or a new design. And you apply those criteria, and you do the operational effectiveness analysis. You couple it with a cost analysis, and you come up with a cost-effective solution. And at RAND, we've done quite a few of these, and I must admit there's always surprises when we do it. Oftentimes, what people think is the obvious solution turns out to be not so obvious. There's also been situations when we've done this analysis where we found for the same capability, you've got two options maybe that afford the same capability, but one is half the cost of the other, okay? So again, I've got to stress when you do these type of things, you really have to do the numbers. And it's also important that we better understand how to allocate the risk, okay, between government and industry. Programs are more successful when there's a clear understanding of the roles, responsibilities, and risk sharing between government and industry, and they should be clearly defined in the concept design phase to prevent future disputes. The government and the contractor should be responsible for the cost and schedule risks in the areas under their respective control. In addition, IP rights and ownership of technical data should be negotiated and needs to be assigned early in the program. As we talk about here, it's important to realize that the ship is integration of multiple systems, and the requirements really need to be clearly stated. The government and the Navy must determine the capabilities desired from the future frigate. Operational requirements define the ship's mission and the operational effectiveness in accomplishing those missions. Requirements also include how the ship will operate and be supported during its operational life. These requirements should be expressed in terms of what is desired, not how to specifically accomplish these objectives, and defined in ways that are agreed on by various organizations responsible, the ship designer, and the builder. In addition, the government should strive to avoid any changes to the requirements that may impact cost and schedule. I'm sure you're all aware that even a minor change to a ship can ripple through the entire ship. Okay? And then, and finally, you have to define how the ship will be tested. On our design considerations, okay, it's very, very important that the designer understand what we would call a duty cycle, and that's how the ship's going to be used. And I think we all recognize Australia has some unique requirements in terms of distances, water temperatures, salinity, heating and air conditioning systems, that because you operate in such a broad range of the climate, And so it's also important to make sure the designs have adequate margins and equipment can be easily removed and replaced. Okay? Another important part is program stability. Shipbuilding programs can take more than a decade from initial concept development to full production. They'll span multiple political cycles, and over that time there will undoubtedly be changes to the external landscape, including new technology developments, industrial-based shifts and changes in national strategy and budgetary priorities. Maintaining program stability in the face of these developments require effective mechanisms to cope with change and to manage the stakeholders. It's important to account for change management processes in the contracting phase and to develop methodology for assessing the cost and impact of changes when they occur. Another important lesson, I think we can learn that from the air warfare destroyer and other platforms, is start construction only when the designs are largely finished. Starting construction on a lead ship before the designs are finalized can lead to costly rework and schedule delays. In some situations, gaps in industrial-based demands may favor beginning ship construction when detailed production designs are still evolving. But often it's more cost-effective to delay construction rather than risk the rework and changes that result from design immaturity. A general rule of thumb suggests that 80% or more of the design detail drawings should be complete when construction begins. Then as we go toward the end of that, we've got the test phase, and that's where the ship performance has to be, the ships have to perform as expected. And some of these tests can begin while manufacturing is underway, but most commence after it ends. There's another thing that is important in consideration early on that really isn't part of the acquisition phases, and that's developing an integrated logistics support plan early. A robust ILS plan depends on a clear concept of how the future frigate will be operated and be maintained, and must be addressed early in the program and continuously refined. It should specify what maintenance and updates are required at different points during the future frigate's operational life, and who will accomplish the required maintenance and modernization. So there's some critical near-term questions facing the C5000 program, and I think a lot of those have been raised in the conference here. You know, really, that do what question? What do you want to do? What is the best cost-effective solution? The ship has to not only be able to accomplish its missions, but do so at a reasonable cost. Is it a MOTS, vol MOTS, or a new design? How will government interact with industry and the program managed? What are the technical requirements and risks, and what risk reduction measures need to be put in place? How will the program office oversee the program? Okay, it's very important that there be one person in charge. Is one of the approaches going to be an earned value management technique? Then finally, as I just mentioned, how the ship class will be supported throughout its life. So these are some of the important aspects that contribute to a program's success. Unfortunately, there's no magic solution to guarantee a successful program. Each new program will be different in some way, and the options, decisions, and outcomes that surround the program will change. Even countries such as the US and the UK, with long histories of designing and building new classes of ships and submarines, and with relatively large defense budgets, have experienced difficulties in meeting cost and schedule goals for new programs. This just isn't easy, okay? All programs experience some bumps along the way, and successful programs anticipate them and plan for their resolution. So what I've tried to do here is kind of identify some key lessons and factors that describe and draw heavily on the substantial body of RAND research on shipbuilding lessons learned. And I think that's my last chart. And I guess we're going to take questions at the end. Okay, good. Thank you.
The subject of my discussion is considerations for building a surface fleet IAMD capability, or originally it was how do you get BMD capability, or the option of BMD capability in the Royal Australian Navy. But really, I think you have to look at it in the context of integrated air and missile defense, of which ballistic missile defense is a subset. I've also will try to capture some of the themes I've heard since this conference started. Admiral Paul talked about distributed lethality. Rob talked about interoperability and integration, was also by General Caligari. All critical enablers. When Admiral Rowden came out with distributed lethality for the U.S., one of the contexts of the discussion was it's not new, but it is a way to explain it so that we can operationalize capability. And so as Australia looks forward in C4000 and follow-on programs, C5000, and other national programs to be part of this concept of integrated air and missile defense, I would offer that the ability to leverage what's already invested on the U.S. side and maintain that interoperability is, frankly, a good step forward for affordability. The ballistic missile defense threat is evolving. One of my key business development guys is the Ayatollah in Iran, and he recently just announced a new Shahab 3 on display this week and a new long-range attack cruise missile, which has a 2,500-kilometer range. So a combination of very long-range weapons and the ability to proliferate them as required in that technology holds forces at risk. It holds national strategies at risk. It can impede how we operate, and it can deny us access. So a lot of talk today about maintaining control of the sea lanes thing, but I also have either good news or bad news, and Mike Moe is in the audience. I got to relieve him in Washington, and on the Australian Air Warfare Destroyer Working Group, Requirements Working Group. And I remember we went through lots of conceptive operations of how the needs of Australia would be met by this new ship. I was fairly impressed by the process. It was well thought out, well conceived of what Australia needed to operate in the future. So as you look at what the threat is out there, kind of what we envisioned the threat was going to be is there. I would say, as was discussed, there's a renewed focus by the U.S. on high-end warfare. There was talks by Admiral Paul. It's been talked to by Admiral Harris last night. The world has changed. We took a tactical pause for a while and focused on other missions. We've returned back to that core high-end warfighting capability. So the other thing I would tell you as you deal with these threats is ships are inherently expensive. That's why we want them around for 35 years. So as my dad used to tell me, choose wisely. So I'll try to capture some of that in the discussion today. Integrated air and missile defense, what is it? Well, it's not a Navy-only fight. It's not a U.S.-only fight. It is a national allied fight. And so that ability to integrate in seamlessly is possible with not just the systems, but the training and the concept of operation to bring forces together to do and deal with this environment is critical. If you do not, someone would say, and I remember this coming up, why invest in all this? Well, politically, let's just say a country near Australia wants to deploy assets to hold Australia at risk. Your option is to take out that asset or diplomacy. If you don't have the ability to engage the threat until you decide to take offensive action, you are in fact at risk. And for those of us who have worn the uniform, that is an anathema to our thought process. So I would contend that investing in the capability to engage threats, whatever it may be, aircraft, cruise missile, or ballistic missile, you should have that capability. And leveraging other assets, such as the F-35. We now have in the U.S. inventory the E-2D, which is interoperable with CEC to the ships, that allows us to use our longer-range weapons like SM-6, and then also do distributed weapons engagement coordination, gets efficiency and effectiveness. So what does it really take to participate in this? What I like to always call the price of admission into the mission set. The ability to have an adequate sensor. Now, the other thing you want to have the ability to evolve that sensor. Can you upgrade it? Can you keep it relevant to future threats? Do you have sufficient resources, capacity? I talked about the battle space. When Aegis went to sea 32 years ago, the battle space was 40 nautical miles maximum for air defense. Now, for air defense, it's 200 nautical miles, engaging objects in space, either exoatmospherically or endoatmospherically, the ability to launch a strike weapon, a Tomahawk, over 1,000 miles away, and having a towed array system that allows you to see further than we've ever envisioned before with a helicopter that can actually go out and prosecute at extended ranges. So the battle space has changed. You have to be able to do simultaneous missions. So I would caution, I know everyone wants minimal manning, so does the U.S., but unless you want 125 Jedi Knights on your ship to operate it, I would suggest that capacity and sailors is a quality also that you should need to consider. Sufficient resources to get the earliest engagement possible for defense in depth. You don't want to be thin, to invest in something that can only engage to a certain distance without having the opportunity to share with other assets to buy back battle space would frankly not be good investment for your Australian dollar. Operational testing. You got to test like you fly. If you don't do that, then you're going to have a lot of discovery. One of the other things you need to do in this is coordinated and in remote engagement. Can you shoot off someone else's data? If there are two AWDs out there, can one share data with the other and fire on the other ship's data? What does that mean nationally? What does that mean for your rules of engagement? All those things need to be considered because you're going to have 3 air warfare destroyers. And to cover a country as large as Australia and defend it or to operate forward, the ability to be seamlessly integrated together is really critical to buy that battle space. You need to be interoperable with all theater assets. Again, the battle space varied long. Japan recently decided to buy the E-2D to supplement its things because they're now interested in what's called integrated fire control. And they want to really stretch the battle space for defense in depth. And they want that interoperability. Experience. A lot of talked about a proven team. Everybody talks about going on a learning curve, investing. You need partnerships that have the depth and the bench, whether it's in industry or within government, and to work together to get that maximum amount of confidence in what you're going forward with. If you choose poorly on those relationships and authorities, as was talked about earlier, you're in for a rough ride. And we have our own mistakes on the U.S. side where we've not done well there. The Australian solution. I guess the point I want to make here is Australia did buy the ticket to go. They paid the price of admission. Now, I would contend the choices for Australia in C4000 and also for C5000 is which movie you want to go to. Is it a movie where you're just doing air defense? Is it a movie that you're doing ballistic missile defense? Is it a movie you want to do them both? Is it a movie you want to have naval integrated fire control? Stretch the battle space, extend it 300 or 400 miles using other sensors data to fire on. You have that ability to do with the things you purchased with the radar, the multi-mission radar signal processor, which enables IAMD. You have the fire control system and the launcher, and you have the Aegis weapons control system. Over 3,000 standard missile firings in the history of Aegis, all both testing and real world. 30 BMD intercepts. You cannot underestimate the complexity of bringing this together. When we roll out against every threat let me give you a ballistic missile example, defense example. If we're running a scenario against one threat for one denied launch area, for one defended area, we normally run over 300,000 analysis runs to ensure that wherever it's launched from, however the trajectory of the missile was, whether it's lofted or depressed, we know with confidence the warfighter can successfully engage based on what the system's telling him. That's a lot of engineering and a lot of work and a lot of analysis, and based on end-to-end performance of the sensor to the missile. It's not bragging, it's just hard work. This is hard stuff to do. And there's a lot of rigor behind it. So I would suggest that investment you've made in the air warfare destroyer, you've bought down the risk and a lot of the cost to go into this mission set, should you choose to do so. The same thing, not just in ballistic missiles, but it do go to NIFCA. If Australia has SM-6 missiles, the ability to take advantage of that kinematic range of that missile, you want to take a hard look at what you do in the baseline to be able to maximize its effectiveness. So this is my, I am a product of Admiral Wayne E. Myers' beatings. He taught us a different way to look at things. In the late 50s, we would build a radar, we would build a missile, and then we would try to make it work together. And we didn't do it very well. And there were a couple of key studies done in the U.S., the Withington study and a Keister study, that led to the formulation of the Aegis concept, what led to becoming known as Aegis. Top-down philosophy from the requirements and the capabilities you want, functionally interfaced, operationally. I'm not going to read your slide, but it was part of Admiral Myers' concept for rigor in the combat systems integration engineering. It has been very successful. As I mentioned, 32 years since Ticonderoga deployed. It is the first combat system that the U.S. Navy has continued to invest in throughout the life cycle. And that's allowed almost the entire fleet, with the exception of some of the early ones that had a different launcher system, to stay in service. And they should, right now they're supposed to have a 35-year service life. And the Navy continues to invest to keep that system relevant. Further evidence, not only did Australia have the system, but you can see the other nations that have invested in Aegis and continue to invest in it. Japan is moving forward with ships 7 and 8, Aegis ships. All will have BMD capability. And in Korea, South Korea is considering 3 more KDX-3 destroyers. So, what's our role at Lockheed Martin? We are the combat systems engineer for the Aegis combat system. We also have the radar and the Mark 41 vertical launcher. We design the combat system spaces and the deck houses. And we integrate and test the combat system in the radar. We produce the major components in the systems, and we integrate and test them completely. Part of the Aegis process is we build it, then we fully test it out and radiate it. So the 3 Aegis warfare systems that you have here ready to go on the ships, and in fact, one of the initials on Hobart, the radars, was already fully tested in Morristown, New Jersey, radiated, and then reconfigured and shipped down here. So we know it will work when it arrives. We do ship integration and test. We will be here as the ship becomes alive to do full integration and testing to validate that it works and make sure everything comes together correctly. And we then provide support at sea. Why is this important? That circle of this, what this describes, allows us to maintain that lessons learned process to roll improvements in the system from the fleet. As the fleet looks at things they want different and more of, we can roll it back in through this process. So it is an adaptable. I mentioned all the successful firings, ballistic missile defense tests, and there's 9 different missile variants, of which 4 in development, that are fired off the Aegis ships today. So it's evolved as no other system we've had in the U.S. Navy before. I talked before about the rigor that goes behind the amount of analysis and validation in the models that we anchor the combat system and the weapon system in, and the missiles. We test a lot. It's very expensive. When I was in Aegis BMD, a typical flight test for Aegis counting the interceptor and the targets and the range time, a cheap one was $40 million to go fire a test. They're inherently expensive. I'm not going to kid anybody, so you don't get sticker shock later on. But again, you can't fail in the mission set. When we started feeling BMD capability, of which there are 33 ships today that can have BMD capability in the U.S., plus the 4 Japanese ships. I would tell the commanding officers, you're not defending just yourself or a carrier anymore. You're defending cities and nations. So you can't screw it up. So you better train hard. You better drill your crews, understand your systems, and make sure they're always ready to go. You cannot fail. So again, this testing include operational validation by what we call in the U.S. DOT&E, or also known as Darth Vader of testing. It validated the system works. So what's next is I would talk to you about what goes forward for Australia and what's the benefits for you. Right now you have what's called a baseline 8 configuration, which is our earliest instantiation of what we call the common source library or open architecture. Why is that important? Well, one, it's designed to operate in a COTS environment, so you get the leverage off the most modern computing software, but it also allows us to upgrade and update quicker and more efficiently and, frankly, cheaper. It allows us a lot of flexibility if you want to have an indigenous systems to integrate in. So U.S. Navy is very excited about it. It's been very successful in Baseline 9, and frankly, it's something Australia should consider because Baseline 9 will be a foundational baseline for everything going forward for the U.S. Navy. Otago and Ashigara are getting backfit with Baseline 9, and the Korean ships will, if they go forward, will have Baseline 9. Very pleased, very complex baseline with a lot of capability. Again, that's the baseline that fully integrates everything I described in this extended battle space. So my contention to you is as you go forward and look at where you want to go with 4,000 as it goes to sea, how you evolve and how you do your upgrades. The other one is for baseline, for C5000, you want to get an open architected environment and maintain that going forward. You'll get the interoperability you seek with the U.S. You will also get the investment the U.S. is making every year, both from within the Missile Defense Agency and the U.S. Navy. All those updates. So the threat evolves, we update the system to deal with that threat. That investment, you get the lift off of. Again, it's not, there is a cost to go do that, but if your cost is borne by the U.S., then that's a good deal for Australia. The other thing is, if you look, I remember the days of Air Warfare requirements, we looked at interoperations with other navies. I think, where the Japanese are, the Koreans are, and the U.S. fleet, that interoperability that comes with what you've invested in is pretty powerful. And so I would say, as my dad would say, you chose wisely. The question is what you go forward with in the future. So I would suggest that you have a great opportunity here. I can't help you on the hull you pick. You'll make that decision. But flexibility. Ships are inherently expensive. There's talk about how many, Rob Elliott spoke, I don't want to buy, I'm not going to buy a tonnage of ship, and it was showed in the middle of the thing. So let me give you this one other thing that's kind of interesting. Norway, their frigates, very good ship. There's only 8 VLS cells. There's room for a lot more VLS cells, should they choose to install them. The space and weight reserved to easily integrate them and add them into the ship. Why did they do that? Because they were looking at cost. They wanted to buy a 35-year ship, but they didn't want to pay for everything on it right away. It's pretty smart. That may be an option for Australia. But if you'd have bought too small a hull, that option goes away. In the U.S., we traditionally look at shipbuilding like this. X amount of tons equals X amount of base cost. Then the next cost is the engineering plan. Then the next cost is your combat system. And that's how we do cost estimation in the U.S. for ships. So those are the trades I would continue to look at. But the good news is you have your foundational pieces in place for going forward. And I think you're going to learn a lot when Hobart goes to sea that you're going to like. With that, I conclude my remarks. Thank you.
I'm here to talk about the benefits of open architecture and common mission combat systems. First off, though, just a little bit about Saab in Australia, just in case you still think we make cars. And please don't panic, I'm operations, not sales. Saab has a long naval history in Australia. We started that transition in 1988 when we transitioned system engineers and software engineers from Sweden to Australia for the commencement of the ANZAC build project. We've continued that involvement with the ANZAC build project as a combat system design authority and combat system integrator, and of course that has included the ASMD upgrade. We've got other projects, other naval projects that we run in Australia, and that includes the LHD, Combat Direction Systems, where we're also the combat system integrator for that system, and we're the OEM for the obsolescence upgrade of the integrated control, ship management and monitoring system in the Collins-class submarines. We've used those system engineering skills and software engineering skills that we've built up over the years to also apply to other domains, being security systems. So now we're predominant in supplies for correctional facilities in Queensland and New Zealand, the immigration facility centres, and also the sites that are being upgraded as part of the base security improvement program. We're now about the same size or equivalent competence and engineering as our sister cousins or old parent in Sweden. So, open architecture and common mission systems. I'm going to try to walk through a few of the benefits and issues, some of the current technology and implementation and what the future may hold, and then just a final summary of some points. Okay, I'm having the same problem Rob had. Okay, the benefits, the cost and risk. Savings across all classes of ships would be expected due to the development costs having already been incurred by the first user to integrate the system. The cost of introducing new capability to install systems is shared amongst the users, so you can amortise your costs over several systems or programs. Tailoring the system may be required for subsequent users, because obviously users aren't going to requirements aren't all going to be the same. But the associated levels of cost and schedule and risk should be considerably less once the original system has been filtered or the core capability has been filtered. Specific capability improvements for an individual platform is still possible, but there'd be low NRE due to the core capabilities existing. The risks would have already been mitigated as well, largely during the development phase of the first user. This is important, though, that you have a continuous build to further reduce your risk, rather than, and I'm talking continuous build, not platform, continuous build combat system. The benefits for support and reuse. Obviously, the major benefits would be through training and the crew. The RAN workforce can more easily be moved between the classes of ship because they're already familiar with the systems and with the equipment. The RAN operator maintaining training courses would only need to be developed once. Of course, you'd expect command team training would be different per class, but then you'd expect a certain amount of commonality to be able to be used through your original operator training. The training infrastructure can be reduced as a crew from the different classes can utilise the same training facilities or equipment. And also the support system infrastructure, such as the system integration facilities, can be shared between the different classes. Obsolescence could also be managed across the classes to find the most cost-effective solution, rather than individual classes developing their own solutions. Supply chain improvements should be possible through shared sparing, inventory rationalisation, and also skilled maintenance. One of the problems we've got currently on a lot of our ships is the maintenance not occurring when it should on the ships or actually being performed adequately. If we've got common equipment, means maintainers do not continuously need to learn new maintenance routines for different brands of equipment, and they just need to keep their skills current. External maintenance and repair should also be more cost effective, with an increased number of systems and a predictable flow of work to the supplier of that system. Systems should be more reliable, and overall, through life support costs would be expected to be reduced. These savings cannot be realised because if the right support arrangements are not in place. You have to have support arrangements in place across the classes of the ships, not specific to a class. At the moment, obviously, that is not the way things are generally done, although there is a trend in terms of common support. There is a common support contracts in place between ANZAC and LHD, and there is also a multi-class platform SPO that is being set up, the old NIPO. So hopefully in the future we will go to future sustainment arrangement will support sustainment across classes. What are the benefits to capability? First of all, a clear functional approach is possible. So modules can be created along warfare lines, and that accommodates different domain logic. You're also able to avoid settling for next best, and you can get the best of breed solution. Independent development cycles are also possible. The modules are able to be developed independently of the core system and of each other. Intellectual property is compartmentalised, and that means that improves your releasability and should remove the barriers to competition. However, like everything with benefits, there are always compromises. So what are those compromises? The system may not provide the capability or performance required for the new platform, particularly if the new platform aspires towards futuristic or beyond cutting-edge capabilities. Countering this, however, if the right architecture is selected, there may be an evolved subsystem that is available with higher capabilities that retains elements of the extant or common subsystem. Of course, the larger the number of customers, the less opportunity that each customer has to drive the future development of that system. This means that customers have to fit in with the development cycle of the product, rather than being able to influence to meet their own specific needs. This is particularly relevant for the RAN, where other customers may have significantly higher levels of procurement, so the ability of the RAN to influence may be reduced. There's obviously also an increased requirement to manage across shared resources, such as training, support systems and inventory. That obviously requires planning, but is achievable. We may get back to the perceived lack of competition, the old value for money, because you're not competing all systems on every platform, so they will need to be overcome. I believe all of these can be managed, but they may need changes to current practices and policies to accommodate. So how do we overcome these compromises in the use of common families of systems for naval customers? Believe through open systems in which software is developed from hardware, software is decoupled from hardware, and you make use of customer open managed standards. First of all, a few definitions, and I haven't made these definitions up. They come from the Department of Defence, US Department of Defence, Open System Joint Task Force. An open architecture is an architecture that employs open standards for the key interfaces within a system. Open standards are standards that are widely used, consensus-based, published and maintained by recognised industry standards organisations. And then an open system is a system that employs modular design, uses widely supported and consensus-based standards for its key interfaces and has been subjected to successful validation and verification tests to ensure the openness of its key interfaces. Traditionally, federated systems have been used to meet specific outcomes, but this is often expensive during the build and far more expensive maintaining one-offs through life. With the move to open systems, the customer must define the level of openness that makes sense commercially and financially, i.e. not all interfaces need to be necessarily compliant to a total open standard. Some interfaces may still be proprietary. To go 100% and have common data models needs significant continuous investment, which may or may not be affordable. As an example of the level of investment required, you could look at the investment the US Navy has made in the Common Source Library and the commitment they have made to continuous development and upgrades. It's something that the RAN would need to consider. What does an open system look like? You can see there's a picture there on the right. It's built on non-proprietary standards. The benefits are obtained when the interfaces between the combat system elements are common across the platforms. A common approach is used to leverage standards and the use of middleware, modules and well-established engineering principles and practices. You are not dependent on hardware and the core framework is built on COTS technology. It's easy to exchange and upgrade your different applications, and there's a reduction in time and effort necessary to integrate the systems together. You're building on a core framework and a middleware and hardware. You're able to exploit the latest current technology advancements across a range of domains without impacting the whole system. So, for the RAN, the module approach supports flexibility and capability options can be determined on a module level. You can allow rapid capability insertion or module improvement, which is a low-risk capability enhancement. The modules also can be made by any competent provider, so you're not dependent on any supplier. The common core reinforces the human element, the usability and the ease of use. A good core makes it easier for module development. The development cycles will promote reuse and give you a reduced NRE and independent development. There is competitive friction to get the best capability. The loose coupling means risk reduction can occur in parallel independent of the core C2 system. In the future, you've got the ability to host various virtual LANs on the same infrastructure. The technology allows for quality of service to be implemented so that you are able to maintain priority of combat systems data. However, you can exploit the available bandwidth for multiple applications. It also decreases the platform infrastructure. You have the ability to insert new capability easily. The virtual LAN hosted on the existing infrastructure therefore can develop new open architecture systems independently or alternatively deploy them as required. We've got examples where this has already been done. This morning we heard where the F125 Common Network has a common network for communications, C2 and integrated platform management system. And Saab has already implemented this solution in our Future Combat Systems Lab and the ESM upgrade currently underway on the ASMD by mixing communications and C2 on the same LAN. Further now, some current examples. So open architecture obviously is here and is progressing. As an example was the EW system open architecture demonstration that was developed. It was a capability and technology demonstrator that was developed between a collaboration between a number of industry participants in consultation with DSTO and the RAN. The EW system open architecture was built using open system principles and it satisfied the system requirements while it's still achieving those open system goals. The model is owned by Defence and could be used as a basis for future naval projects. This is just an example. This is the architecture that was used. The important thing here is it's built on an open architecture bus, and this is 100% open architecture, open standards data model. So this is the full. The modules were developed from the different companies. Not only that, they were developed at different sites and different areas in Australia and integrated with minimal effort. Another example is on the Halifax class, which is the Halifax class upgrade of the Canadian frigates for, obviously, the Canadian Navy. Saab and Lockheed Martin have produced an integrated solution for Halifax. This uses open architecture where the modules have been split between Saab and Lockheed Martin, and they're built on a core system. There is COTS hardware and middleware. So this is the open system that's been developed there. So in summary, for common mission systems, you'd be expected to achieve a reduced costs and risk. Development costs for the core capabilities are able to be amortised over a range of programs. Risks for core capabilities are identified and mitigated, not again and again. Mitigated once, sorry. This enables training facilities also to be shared, and shared maintainer and operator training is also possible. The crew is able to move more easily between the different classes of ships. The number of land-based test sites, integration test sites, can be rationalised and should be able to be significantly reduced. Significant supply chain improvements are possible. The rationalisation of inventory and spares available when required. You should achieve more effective maintenance. Obsolescence is managed across the classes. All of these should result in an overall reduction in the total cost of ownership. All of this relies on investment up front to commit to continuous improvement and open systems, open architecture, key open standards. So we need to ensure that we are serious about the common mission systems and it's not just words. Thank you for listening.
Right, good afternoon. By my calculation, we're 19 hours into a 20-hour event. So we're in the home stretch. Now, I could take a combat system view of that and said we spent far too much time in the schedule worrying about shipbuilding. Or I could take a view that says now it's entirely appropriate we talk about industry's contribution to future shipbuilding in the country. I think the scene has been very well set. So Chris opened it up, and I've got to applaud his comments in regard to the importance of systems engineering when we start talking about shipbuilding. And then I think John and Brad and Cheryl have set up the scene, which I hope I can close out on behalf of the panel. So from the outset, I'd like to say that we should recognise that Australia's defence industry is the product of 2 decades of government policy. During that period, Australian defence industry has grown from being little more than a provider of goods and services, products at arm's length, now to an integral element of Australia's defence capability. This means that our relationship with defence has become more interdependent. At our best, we are trusted partners of defence, sharing our combined intellectual, technological and human capital to ensure the Australian Defence Force can deliver on its operational outputs and contribute to mission success. With this in mind, I would encourage each of us to view Australian industry as an integral element of defence capability, especially as it applies to the future surface combatant fleet. This means that we must accept that defence industry is a fundamental input to capability. In turn, we need to mature the relationship between defence and industry from purely transactional and arm's length to a more strategic partnering arrangement. If we don't make that fundamental change, then we will collectively struggle to meet the challenges of delivering on programs that are becoming increasingly complex, of higher value and higher risk. And of course doing this in an environment of dynamic tension between a greater drive for innovation and a continuing need for cost improvement. A more strategic partnering arrangement involves a greater emphasis on fostering better long-term relationships between defence and industry and the use of innovative commercial tools to best leverage those relationships to deliver the desired outcomes. This must be underpinned by a greater openness and transparency, with a common and more explicit understanding of how we achieve the best value for money for defence and a fair return on investment for industry. It's this win-win approach that will drive improved outcomes for the warfighter and better value for money for the Australian taxpayer. From the earliest stages of a product life cycle, we should establish relationships with any necessary commercial relationships which are based on a mutual understanding of what the motivations and interests of each party are, to acknowledge and manage the areas of difference and tension. This willingness to share information with industry in a spirit of openness and transparency is key to the successful delivery of capability. Transparency must include engaging industry early to harness the collective knowledge and experiential learning to better inform defence procurement and more effectively facilitate the desired capability outcomes. An example of how industry in partnership with defence is providing long-term capability to Australia is the NOLCA program. Here, a strategically cooperative approach has produced a capability and cost benefits while receiving a world-class active decoy system. Another was realised on the Air Warfare Destroyer program, where it's widely recognised that early teaming and collaboration between Defence and the mission system integrator helped to refine the AWD concepts, aligning the required capability and available technologies, budgets, year of delivery targets and other program constraints. This early collaboration has mitigated the risk for the delivered mission system capability falling short of capability expectations. I believe the next opportunity lies in the approach to be taken in the delivery of the Navy's future surface combatant capability. We can no longer afford to reinvent the wheel every time we embark on a new naval program. Rather, we must move away from the old stovepipes of platform-centric views and take a system of systems view. This would see a transition to a new paradigm which takes a surface fleet view, where the sum of the capabilities of the fleet are greater than the capability contributions of individual fleet units alone. Instead of taking a constrained platform-by-platform view, it would be elevated to one focused on a system of systems view. The aim would be to achieve, at a minimum, an implicit fleet interoperability with maximum commonality across mission systems. This approach implies the need for high levels of commonality, interoperability and interchangeability between fleet units to better realise the benefits of emerging capabilities and to build on existing capability investments. Such an approach would be especially important if we are to grasp the benefits of network-centric warfare alongside our allies, and in particular the US Navy, to deliver an operational advantage. The first step in this system of systems view is to adopt a common mission systems architecture where we can take advantage of our existing investment to reduce the cost of ownership for the future surface combatant whilst maximising its capability. When it comes to the future frigate program, the publicly declared requirement is for and I quote, a multi-purpose surface combatant capable of operating across the full spectrum of maritime operations. This includes low-level constabulary operations through to high-end warfighting with an emphasis on anti-submarine warfare, unquote. These missions will necessitate a considerable step change from today's ANZAC-class ship capability. In the current budget and the constrained environment, Defence is also looking to achieve this capability outcome in a cost-effective and low-risk way. Equally, there is a requirement to ensure that all of Navy's surface combatants are able to cost-effectively and incrementally evolve in order to counter emerging threats over the life of type of the platforms. These requirements, both the life of type capability requirements and those of cost and effectiveness, present a considerable challenge. But they also present a significant opportunity to take a whole of surface combatant approach and deliver such through a strategic collaboration between defence and industry. Such a strategic collaboration should leverage existing in-country capabilities across the entire surface combatant enterprise and build on the considerable investment already made by stakeholders. This should not be done to support a rent-seeking industry, but rather to continue the development of more efficient and cost-effective ways to deliver and maintain such a sovereign capability throughout the life of type. Let me now move away from the concept of a common mission system architecture for the future surface combatant and address some specific examples. A fleet-level common mission system architecture approach that is implemented through platform-specific design changes, yet managed at the system of systems level, would allow us to leverage off historical investment and facilitate the full exploitation of innovation programs. Examples would include building on such programs as the successful ASMD program and the Australian United States Phased Array Radar Project, or ASPI, to realise benefits to defence. And I think Cheryl ran through these pretty well. Reduced cost through avoidance of non-recurring engineering effort, reduced integration risk associated with evolving mission system capabilities customised for each platform, and lowering the whole-of-life costs through commonality and economies of scale. The other important example is the Air Warfare Destroyer program, which has represented a major undertaking in naval mission systems design and integration since first pass approval back in 2005. The fact that the integration activity has been successfully undertaken to date is evidenced not simply by the achievement of metrics for cost and schedule, but by the fact that the risk has been significantly reduced by rigorous shore-based testing of some 87% of the combat system interfaces. The remaining interfaces are considered low risk and not requiring such testing. Over 4 years, a team of dedicated systems engineers and technicians from multiple organisations, government bodies and global equipment suppliers have worked towards this outcome. In this circumstance, there is genuine interest involved in reaping a full dividend from the substantial investment in the AWD mission system architecture. It's our combined experience drawn from the investments we've made in AWD, ASPI and ASMD projects that give the best opportunity to reduce time, risk and budget for future frigate. In terms of reducing the upfront engineering and verification effort for future frigate, this translates to shaving years off the schedule and potentially hundreds of millions of dollars off cost. This is particularly important when the next generation of capabilities are considered, and there will inevitably be a need to introduce off-the-shelf based US weapons or technology to the fleet to counter emerging threats or for customising a platform or system for a particular mission. Our combined experience can therefore future-proof us as we go down this growth path. For example, the current AWD mission system architecture has been developed to facilitate long-term capability growth and for the management of obsolescence. One of the key architectural principles employed in the development of this mission systems architecture is to facilitate interoperability with the ADF and allied, particularly the United States Navy, task groups. In future task groups, key technological force multipliers will be expanded use of secure sensing network technologies. For example, the Cooperative Engagement Capability, or CSC. This will enhance situational awareness between each fleet unit and enable the fleet assets and their long-range munitions to be utilised in a networked force. These technologies will also become key capability discriminators for the Navy's future surface combatants. Reuse of the common threads of the AWD architecture and the associated USN technology roadmaps will also be essential to maximise the capability advantage afforded to the Royal Australian Navy through a USN coalition. A common mission system thread, I say, in command, control and decision support systems enabled by the open standards will be critical for the Royal Australian Navy. This will not only allow the continued deployment of the current inventory of weapons, but maintain a route to evolve the mission system to the next generation of long-range weapons and potentially the assignment of a ballistic missile defence mission. Alignment with the USN weapon roadmaps, including torpedoes and potentially strike missiles, promises not only advanced capabilities and improved interoperability, but also delivers economies of scale, shared certification costs, and in-theatre sustainment opportunities. Consistent with the Defence Minister's announcement in June last year, the mission system architecture of the future frigate will be required to incorporate the leading-edge, locally developed radar technology proven by CEA Technologies in the ANZAC ASMD upgrade. In addition, the mission system may incorporate a further evolution of the radar suite for longer-range surveillance and for fire control support of the standard missile family of weapons. The system performance requirements and the insertion of Australian capabilities such as the CEA radar are all requirements that can be satisfied with relatively low risk and in a cost-effective way by reusing the common threads of the AWD mission system architecture. In order to develop the common mission system architecture, it will be appropriate for the early engagement between defence and industry on that mission systems integration. The challenge for defence in delivering a common fleet mission system architecture will be met through strategic partnering with the industry's mission system engineering capability, which would be responsible for designing systems for efficient upkeep, update and upgrade through life, integrating system of systems and integrating Indigenous subsystems or software applications into the foreign supplied systems, such as those often sought from the US. The mission systems integrator will understand that individual mission system designs will evolve with new technology and with new capability needs over the life of the platform. A system of systems approach is used to manage this change by leveraging off the concepts used in commercial industries, such as using stable reference architectures. New design instances can then be managed as separately controlled changes without undertaking any change to the baseline architecture. Once a common architecture is adopted across the surface combatant fleet, the next challenge will be to achieve further cost savings and advantages by developing a focused fleet-wide baseline management approach through collaboration between defence and industry. It should come as no surprise that Australia needs to have such capabilities as retaining mission system integration capability in country. It is a matter of national sovereignty. Developing and growing our industrial self-reliance, especially in mission systems integration, will be critical to the mission's success, particularly during times of tension when the Australian surface combatant fleet will need interoperability at the core of its operations. Further, the protection of intellectual property of US-supplied defence technology such as naval weapons and sensors is a matter that the United States will be increasingly expectant of Australia to perform. All this places high value upon maintaining an Australian industrial capability in mission systems integration and in system-level sustainment. In this very important phase of the Defence White Paper's development, when we may assume key decisions are being made before the finishing touches are being applied, Defence has an opportunity to recognise the important contribution that our defence industry has and will make to naval capability. The upcoming policy statements in the Force Structure Review and the new Defence Capability Plan will, I hope, promote a sustainable and globally competitive naval industry capability to support not only the future frigate program, but the wider surface combatant fleet. This capability should be able to deliver a common systems architecture across Navy's future surface combatant force of AWDs and future frigates. Through this implementation, the Royal Australian Navy would achieve a range of benefits, culminating in reduced whole-of-life costs for the fleet and the reduced risk of managing the execution of Navy's mission system capabilities. The successful delivery and commissioning during the next decade of the interoperable next-generation networked future frigates, when the ANZAC class and their long and meritorious service will have demonstrated defence industry cooperation at its best in serving the national interest. Thank you.
So there you have it. Picking winners is dead easy, isn't it? Okay. Well, we kicked off with John's introduction, where I think is a very timely reminder of one of the irrefutable laws of defence procurement, and that is that the more you change and develop in pursuit of what is an almost irresistible desire for greater capability, the more risks you take. That risk will always manifest itself in more money and more time. How much is about how well you execute those changes, but you can't dodge the bullet in terms of the connection between change, development and time. We've had a couple of really interesting presentations on the combat system front from Alan, where I think he's very eloquently put the case for sticking with Aegis and all the wondrous work that's been going on the air warfare destroyer. Cheryl gave us a presentation where she talked about open architecture, but I suspect was also making a bit of a pitch for sticking with some of the excellent work that's been going on the ASMD ANZAC development. So I reckon that's two options on the combat side, but I think it wouldn't take us long to find a couple more. So we've got at least 4 different ways forward on our combat mission system. Put that with the earlier discussions we had about platforms. By my count, I reckon there's 4 or 5 credible platform solutions. So our procurement executive, whatever form they're going to take in the future, I've already confronted with a 4x4 or 5x5 matrix of options to assess, each of them offering different starting points, different projected capability and different levels of risk. So it's going to be an enormous challenge for them to pick their way through that and, in a fact-based manner, make judgments about the relative merits of that over 25 options. And then Michael very kindly, I think, took us back to what is, might argue, the third dimension of the matrix. And the third dimension is, once you've picked your combat and platform, the way that you manage and execute that project has a fundamental effect on its outcome as well. And there are a number of different options there in terms of how you manage it. A system engineering perspective, there are other models out there. So in fact, we've now got a three-dimensional matrix and probably closer to 50 different permutations to pick our way and find the sweet spot of the perfect answer for Australia. I don't know why we don't just get on with it and get it all sorted by next week. Okay, questions? Does anybody get any questions? I'm sure we can find something in there. Or while you think, I've got a couple just to keep us going. John, we heard earlier today that from Colin Thorne that we're up to, 180 hours per compensated gross tonne for air warfare destroyer, which is obviously causing much consternation in the shipbuilding community. I wonder if you could just give us your thoughts based on experience in other countries in the UK and the US, as how much you think of that effort is linked to the quality of the engineering effort and the engineering inputs versus the intrinsic capabilities of the tradespeople in Australia?
That's really a good question, and I think a lot of that is due to the episodic nature of shipbuilding in Australia, the start and stop, not the continuous build strategy. The problem I'm facing is that we've done some work in that realm, and it's been kind of sensitive, and I've been asked not to comment on it. So, but what Colin said this morning was absolutely correct. So I apologize for not expanding a little bit more on that topic. But there's more to come soon, so you'll get to see exactly what was done and how it was done.
Michael, do you want to have a chip in on something there? No. We take the fifth on that one. Okay. Steering away from the technical side for a moment. Commercial models. We've talked a lot about not only is it the technology that you pick and the people you pick, it's how you organise yourself and manage it. And again, earlier today we heard some of the people talking about the lessons learnt from previous programs. So what did the panel think about what would be their preferred model in terms of organising for the future surface combatant? And there we can talk about alliances or prime contracts, or what other models do we think would be a way in which we could actually address the effective and efficient management of this project under a commercial framework? Nobody wants to go. Someone's got to have a go at that.
Well,
Michael.
I'll comment. I mean, I think it doesn't matter which commercial model you try to apply, each has their benefits and their weaknesses. And perhaps alliancing is not the flavour of the day as it stands at the moment. But you've also got to look at it from the perspective of, with the amount of change that happened on the program, the amount of scope movement, etc., that has existed on the air warfare destroyer, had we entered into that arrangement in the traditional prime sub, or indeed in two separate contracts, we would run the risk at this point in the program perhaps being buried by paper, as each side decided to officially record their position in regard to change and scope movement. So in that regard, the alliance has been quite successful in avoiding that level of bureaucracy and claim on claim that might go with that. Obviously, there are weaknesses that go with the alliance. I think if you stepped to a different model where you said that there were two contracts, one essentially for mission system and one for shipbuilding, then of course you've also got issues in regard to how that gets managed, because in essence that puts the Commonwealth in the prime position where they've got to deal with that. So I think all the models have benefits and weaknesses, and what will be important going forward for future frigate is that those benefits and weaknesses are understood at the outset of the program and significant mitigation is put in place so that they can be managed.
Thank you. Is there the US perspective there? I mean, what's the protocol in the US? What's the preferred model out there?
Like anything, there's options. If you take the U.S. model that Admiral Meyer put in place, you have the overall combat systems integrator. But Admiral Meyer's staff and the program office served as the overall integrator over the shipyard and the combat systems integrator. And he viewed the ship, the platform, as and he hated the term platform. The ship had to meet certain functions to support the combat system. So in that case, the combat systems integrator drove the shipyard to meet those housekeeping support requirements. But if Australia can't build a foundational program office inside the government that is capable of managing that, then that model won't work. Because that assumes the government has a certain level of equal competence to the combat systems integrator and to the shipyard within its talent. If that's not possible, then you have to go with a different model. I would contend, though, that there can only be one person in charge. Somebody has to be singularly accountable, short of the DMO, for God's sakes. So figure out who that is, and then empower them to make the right decisions working with the Royal Australian Navy so you can execute the program and have some chance at success. I would also, one other thing, I'm almost tired of hearing about the Valley of Death at this point. Smart people can figure out how to deal with that. To say it's a fait accompli is to me, that's just not, that's admitting failure. I think Australia's smarter than that. You can figure out how to do it.
Anybody else? John, you want to perhaps throw in the European, British perspective?
Again, I think I'm kind of in an awkward position. I just have to say there's more to come shortly. And unfortunately, I'm a little embarrassed by my meager response, but it is what it is. I've gotten certain instructions, and I'm obeying them.
We all have anticipation, though.
Well, that's good. I hope so. I think it will help shape the debate. And again, it's a typical RAND type of thing where it's very quantitative. So.
Yeah, but I think, I mean, obviously, on behalf of the European story. The European story, I guess, has always tended to follow the US perspective, but they've felt the limitations of the procurement agency taking on the prime of prime roles more acutely than perhaps the US have in recent times. So they've struggled with having enough competence to be able to manage that interface between combat and platform systems. And I guess that's Australia's getting similar experiences at the moment. So that third party, and are they credible and can they be put together to support these programs, is a crucial another piece of the story. And if you're not confident about that, then that does tend to drive you to different models, doesn't it, to address that particular shortfall. Still no questions? Third and final call, because otherwise we will call an early close as we try and avoid the stampede for the airport. But I think we're going to ask Peter to come and give up some closing remarks. So over to you. Thank you very much indeed, panel.
Well, ladies and gentlemen, quite a few of you look as though you've gone through sort of 2 days of a cage match with a large bear. It is amazing how you get to the end of a conference and feel quite so exhausted. Those of you who came to our submarine conference last year will know that it was at precisely this time that we had probably the feistiest intervention from the floor, and I was alarmed and alert at the thought that there might be yet another major surprise like that happen at this one, but not so. It falls to me to sum up or attempt to sum up some thoughts over the last couple of days. You'll be pleased to hear I'm not going to give a session-by-session or speaker-by-speaker summary. It's been an intense experience. We've heard from around 20 experts from both sides of politics, from the war fighters, from industry specialists, and a wide range of individuals with deep expertise on these issues. So no summary here. There's a lot of food for thought, and it's going to take some digestion. But I do want to offer some perspectives on what we have learned and the challenges that I think we face going forward. Now, the first thing I wanted to note is that the Defence First Principles Review document was released earlier today. The Minister gave a press conference about 1:45 up in Parliament House. I think you probably know the senior leadership group of Defence was briefed an hour or so before that time. Now, I have, in many different professional capacities, lived through almost 10 continuous years of reviews into defence structure. And what I can say is that the First Principles Review offers a very substantial organisational redesign of the defence world, which is going to be highly relevant to the issues that we have been talking about over the last couple of days. So DMO and the Capability Development Group will be disbanded, that's the word the review uses, and moved into a new Capability Acquisition and Sustainment Group. The service chiefs are going to be taking on a stronger capability management role, even at the same time that the Defence Act is revised to remove their statutory capacity to engage the Minister. The Vice Chief is taking on more authority as a truly joint capability manager. And the Deputy Secretary for Policy and Intelligence is going to have a greater capacity to robustly test force structure proposals. Now, something that's relevant to us here today is that there's going to be a 2-year implementation phase. In some respects, quite a rapid implementation of some major changes. And I think it's fair to say that the government has bitten the bullet on substantial reforms. Now, it should be noted that all of these changes and implementations are going to take place in exactly the same time frame that critical decisions about C1000 and C5000 decisions are going to be made. And you can appreciate that what this means is that an already very high bar has been lifted again on the government and on the defence organisation in terms of its capacity to deliver these projects. So that's the broader context of what we've been talking about over the last few days. Now, some of you may accuse me of being a hopeless optimist, not something I would often be accused of, actually, but I think it's fair to say that from the Minister and from Mr Feeney's presentation, there are some shared perspectives which emerge even under the surface of some largely articulated differences. It seems that both sides of politics are now agreeing to the idea that a continuous build approach is necessary to sustain a vital industry base for Australia. Now, if that's right, that is a really important outcome. And it says that a shared outcome has arrived because a lot of things can potentially flow from that perspective. It seems that there is indeed a willingness to consider building C5000 in Australia, so long as the right measures are put in place to lift productivity. Now, I think it's also fair to say that by itself, C5000 is not going to be a solution to continuous build. And so one of the challenges that will be faced by industry and by defence is how to manage that framework beyond the future frigate project. Now, I conclude, I think, that an urgent requirement is to quickly settle the future ownership of ASC. I know that there is a growing private sector appetite to be involved in various commercialisation options. And my view is that in order to enable effective decision-making for a number of these major projects, the government should make a priority of settling ASC's future. Private ownership of surface fleet construction and of submarine maintenance and sustainment would surely help address issues of productivity, of long-term workforce needs, and of the best way to use the facilities to support the drumbeat of continuous construction. I also think that is the most effective way to address the so-called valley of death. I agree with the Admiral who was speaking previously that, you know, we shouldn't regard this as a council of despair. I think we need to look, though, to sensible private sector ways to address that workforce issue. So if my characterisation of the Minister and David Feeney's speeches are right, I think this moves us a little way towards a bipartisan and sustainable policy on shipbuilding. Now, a separate conclusion I draw is that there's a large-scale consensus around the need to be clear on the strategic purpose for C5000 frigates and for other surface capabilities. But again, I think the conference has revealed we're a long way to get a clear and agreed picture of the strategic rationale and the right capability definitions. I think we need to have a deeper and more serious look at other international approaches, the Brits, the Germans, those savvy dollar-squeezing New Zealanders, and indeed many others, as to what approaches can we copy or adapt. Now, again, also, I don't see too many convincing signs that we're being innovative enough in looking at our capability options. And on this point, as a person with a background in strategy, I have to say developing capability definitions without regard to funding realities is just fatuous, right? Strategy without money is just fantasising. The two have to be sensibly addressed together, and that means to say our financial situation has got to be an early part of consideration for the capabilities that will flow with those resources. So that means we've got to look intelligently at how to consider different levels of capability across the ship build. Surely that's inherent in the idea of spiral development. And we need to make sure we've incorporated best international thinking into things like, for example, crewing options, integration opportunities, the use perhaps of uninhabited systems and other emerging technologies. Now, another conclusion I draw from the discussion is to say that clearly interoperability between allies and friends is critical. We face a future where there will be smaller navies with fewer ships, and that means they will have little option other than to work more closely together. So this means how Navy engages with friends and allies is going to be a much bigger part of thinking about priorities for design during capability development. Now, on the defence industry relationship, I can't escape the conclusion that we have to get a whole lot better at building trusted and respectful relations. In part, I think the first principles review is designed to try to shape different behaviours. So, for example, it aims to find strategies that will create a closer and earlier industry role in capability development. And it seeks to downplay competition at the expense of cooperation. C5000, I think, will provide an early and critical test of our ability to build a more mature and less adversarial relationship between defence and industry. And on that, I agree completely with Michael Ward's observations towards the end of the session. This is the fundamental challenge. You know, we have to work out how we can treat industry as a FIC, a fundamental input to capability. That's the critical benchmark test. If we don't pass that, I think so much else will fall by the wayside. And on C5002, I think a critical test is also going to be whether or not it is possible to sustain a more bipartisan relationship between government and opposition and between state and federal governments. If we fail to do that, as I said in my opening address, the critics and the custodians will continue to swap their roles over time, fouling each other's nests as they go. I can only agree with John Caligari that integration remains a major challenge for the ADF. It's clear that we're not there yet in terms of our planning and our processes. And again, a major element of the first principles review is to lift the role of the Vice Chief in promoting better integration strategies. Now, we all know, of course, with reviews that the main challenge is the implementation, and it's now going to be able to prototype itself, I'd suggest, on C5000. The timing makes it inevitable for that to happen. So, ladies and gentlemen, we come to the end of two rather intense days, and it's only appropriate that I express some thanks and gratitude at this point. Gratitude that we have indeed come to the end of two rather intense days. But thanks also to ASPI's sponsors. You see their logos up there on the wall. For without your interest and support, we would not be able to undertake this type of work. Now, my ASPI team has sort of snuck artfully into the back of the room, and many people, it's fair to say, have put in a very substantial effort over quite a few months to bring us to this point and the completion of the conference. But at the risk of being slightly unfair to all of you guys, I do only want to mention two people in particular. One, Ben Schreer. Ben has carried much of the workload for this event. He's done so with great commitment, with a real desire to keep the trains running on time and with good humour. Thanks, Ben. I really do appreciate your work. Thank you. And I particularly want to thank Lynn Gossard as well. Quite a number of you, I think, would know Lynn. She's been our event manager at ASPI for well over a decade now. Lynn is moving on to better and hopefully more enjoyable things in the north of Tasmania, in a rather wonderful little place called Burnie. Lynn, we're going to miss you enormously, I have to say. But the good news for you is you will never have to worry again about organising the seating arrangements for a 250-person dinner. That's about the size of the population of Burnie, so I don't imagine that you're ever going to do that again. But can I ask you all, please thank Lynn and all of the ASPI team for their work. And thanks to all of you. Thanks for your attention and your interest. To our speakers, who have some of whom have come formidable distances, thank you for your commitment and valuable ideas. Safe travels home to all of you, and happy Easter. Thanks very much.